morning. Today we will be discussing about Wiler-Atherton polygon clipping algorithm. The objective of this algorithm is to clip a subject polygon with respect to a clipping polygon. For example, here in this case, as per the figure, A, B, C, D, E and A is our subject polygon shown in orange color, and P, Q, R, S is our clipping polygon. Clipping polygon need not necessarily be a rectangular or square window. It can be of any polygonal shape. Now, this algorithm, Wiler-Atherton algorithm, overcomes the limitations of the Sutherland-Hodgman polygon clipping algorithm, as Wiler-Atherton polygon clipping algorithm works well not only for convex shape polygon, but also it works well for concave shape polygon, because it does not generate any extra edges for concave shape polygon as it usually does for Sutherland-Hodgman polygon clipping algorithm. So Sutherland-Hodgman polygon clipping algorithm is already being discussed, so I'd request all of you to visit once again to brush it up. And in Sutherland-Hodgman polygon clipping algorithm, we have seen that it works well for convex shape polygon, but it does not work well for concave shape polygon, as it generates extraneous edges for concave shape polygon. Now, before going to the detailed discussion of Wiler-Atherton polygon clipping algorithm, let me talk about what is convex shape polygon and concave shape polygon once again. So convex shape polygon is a polygon in which there will be no interior angle whose size will be more than 180 degree. So all the interior angles will be having angle less than 180 degree. And in case of the concave shape polygon, there would be at least one such interior angle whose value will be more than 180 degree. Like in this figure, the polygon A, B, C, D, E, F, the interior angle CDE is having more than 180 degree value. So I hope the difference between convex shape polygon and concave shape polygon is clear. Now for this kind of so what is this polygon? A, B, C, D, E, F, G. It is a concave shape polygon because this angle is having more than 180 degree value. The angle DEF, the interior angle DEF of this polygon is having more than 180 degree value. Now if we would like to clip this subject polygon with respect to this clipping window, in case of using Sutherland-Hodgman polygon clipping algorithm, what we will be getting is like this. So this is our clipping polygon window, and we will be essentially get this sort of and along with this there will be an extra edge will be detected. So effectively this region will be detected as the clipping region. along with these extra edges. So if you apply the Sutherland-Hodgman polygon crimping algorithm, we will be getting this sort of figure. Along with this, there will be an extra edges connecting between these two clip region. These extraneous edges is actually the limitation of the Sutherland-Hodgman polygon crimping algorithm. Now, to overcome this problem, the Wiler-Atherton polygon crimping algorithm is being proposed. So, let's consider one example. Let us consider that A, B, C, D, E is a polygon, which is of course a concave shape polygon, as it has an angle greater than 180-degree value, interior angle greater than 180-degree value. Therefore, it is a concave shape polygon. Now, with this, we will discuss how the Wiler-Atherton algorithm works. And this is our subject clipping polygon. Sorry, PQRS is the clipping polygon. Now, the algorithm works as follows. In the first, this Wiler-Atherton algorithm uses two lists of vertices. One list is used for subject polygon and another is used for clipping polygon. So, how the subject polygon list is generated? The list of the subject polygon, as you can see here in this figure, will be generated by considering a starting point. Let's say A is my starting point, and considering A as the starting point, we will follow the edges of the subject polygon in ascending order, and we will list the vertices of the subject polygon as we proceed in the clockwise manner of the subject polygon. Along with that, we will also include the intersection points of the subject polygon with the clipping polygon also in the list. So effectively, what we will be getting, in the list, if we start from vertex A, we will have the vertex A in the list. First, we will get the vertex A in the list. Then what we will get? We will get the vertex B in the list. So this is the vertex B. Then what we will get? We will get the intersecting point. Let's say this is I1. So that will also be included in the subject polygon list. So I1 is in the list. Then what will be there? So following the edge in the cyclic order, so we get that next vertex is C. So C will be included in the list, followed by the another intersecting point I2 will be in the list, I2. Then following the list in the cyclic order, following the edges of the subject polygon in the cyclic order, we get the vertex D. So D is included here. Then we will get the another intersecting point I3 in the list. So I3 will be included in the list. Okay, then we will get E, vertex E, then followed by E. Then again in the cyclic order we reach to the intersecting point I4. So I4 is included in that list, and then we reach to the point E. So that's what is the list of the vertices in the following the cyclic order of the subject polygon. We get A, B, I1, C, I2, D, I3, E, and I4. So another list which I have just mentioned, that is to list the vertices of the clipping polygon along with the intersecting vertices. So in the clipping polygon, if we start from P following the cyclic order, the vertices will be P followed by the I4 point, the intersecting point I4, then I3, then I2, then I1, then Q, and then in the clockwise manner, if we proceed, that will come across Q, then R, then S, then P. So following the clockwise manner, we get the list of the vertices as P, I4, I3, I2, I1, Q, R, and S. So these are the two list of vertices which we get following the edges of subject polygon and the clipping polygon using clockwise manner. And there, please note that the intersecting points are also included in the list, both the list. So now what algorithm it does is that once the vertex lists are generated for subject polygon and for clipping polygon, next step is to locate the first intersecting point for which the the incoming edges enters from outside to inside of the subject polygon. I repeat, once the two lists for subject polygon and clipping polygons are generated, then we will start processing the subject polygon vertices in the clockwise manner to find out the first intersecting point for a subject polygon edge with clipping polygon which enters the clipping polygon. That means in the list of the subject polygon vertices, if we observe which are the intersecting points, I1 is the intersecting point, I2, I3, and I4. In the ordered list of this cyclic order of the arrangement of the cyclic order of the subject polygon, if we observe, then we come across first intersecting point I1, which is generated by the incoming edges B to C, which is generated by the incoming edges B to C following the clockwise direction of the subject polygon. We first get the first intersecting point as I1, and we will start that as the starting point of the vertices. So I1 is the starting point. Then it will proceed to the next step as follows. So in the list, I1 will be stored. The first intersecting point I1 is the first intersecting point of the incoming edges of the subject polygon entering into the clipping polygon. So I1 will be stored, and from I1, once it is detected, from I1, start from that intersecting point, then follow the subject polygon edge in clockwise manner again, and go on storing the vertices till it finds an intersecting vertex for an outgoing edge of the subject polygon. So starting with the first intersecting point of an incoming edge of the subject polygon, will start following the edges in the clockwise manner, start following the subject polygon in the clockwise manner, and go on storing the vertices till we do not find any intersecting point for an outgoing edge of the subject polygon. So once we found the incoming edge I1, then uh, if we go on following the subject polygon edges in clockwise manner, we find next point will be C, then the next intersecting point is I2, which is actually uh, generated by the outgoing edge C to D by the subject polygon. So we will stop there. So starting from the first intersecting point, we will go on storing the vertices following the subject polygon edge in clockwise manner till we do not find an intersecting point generated by the subject outgoing edge of a subject polygon, outgoing edge of an subject polygon with the clipping polygon. So therefore, the next intersecting point I2 generated by the outgoing edge of the subject polygon is I2. Therefore, we will store I1, then C, then I2. So the we will store I1, C, and I2. So we have stored I1, C, and I2. Okay, in the output vertex list, I1, C, I2 is stored, and then we will be proceeding in this way I2 in the subject polygon, and once we reach to a to a intersecting point generated by a subject polygon, um, then we will move to the clipping polygon list. Then we will move to the vertex list of the clipping polygon, where the that intersecting point is located. So we find that in that list, the vertex list is here. I2 is located here in this point, and from that point we will start scanning it in the forward way, that means in the clockwise manner, such that the previous intersecting point was I1 is reached. So from I2 we will proceed forward in the clockwise manner until we get the previous intersecting point, that is I1 in this case. So from I2 we will follow the edges of the clipping polygon. So from I2 we will follow the clipping polygon edge, and we will go on storing the vertices until we do not get the previous intersecting vertices of the subject polygon. So we get here I1. So there we will end this sub procedure. Then we reach to this point I1. So therefore, what essentially we are getting, we are storing the I1 vertex followed by the C vertex and followed by I2 vertex following the subject polygon edge, and once the I2 point, that means the intersecting point for an outgoing edge of a subject polygon is made, then we will consider the clipping polygon and we will start proceeding following the clipping polygon window, clipping polygon edge in the clockwise direction till we do not reach to the previous intersecting point I1. So we get the vertex list I1, C, I2. Next, what we need to do, we need to proceed from the subject polygon, means once the intersecting point is reached, so we will proceed from the subject polygon once again. So once the subject polygon is reached, next list, from the next list, what is the next intersecting point for an incoming edge? The next incoming edge is the intersecting point is I3, which is generated by the incoming edge of the subject polygon DE. So therefore in the list also you can see that next intersecting point is I3, which is due to the incoming edge DE intersecting the clipping polygon. Therefore, we will start again, restart the procedure from I3, and uh, we will start following the procedure by tracing the subject polygon edges in the clockwise manner. So starting from I3, if we follow the subject polygon edges in clockwise manner, uh, we get the vertices E, then I4, and this the tracing of the subject polygon in clockwise manner will be done until we do not get any intersecting point for an outgoing subject polygon edge. So here we get the I4 as the intersecting point for an outgoing edge EA of the subject polygon. Therefore, we will stop the procedure at I4. So the I3, E and I4 will be traced. These vertices will be also stored, I3, I4. Then from I4, since this is the intersecting point for an outgoing edge of the subject polygon, we will start scanning the clipping polygon. We will start scanning the clipping polygon edge in the clockwise manner. So that means from I4 we will start proceeding the clipping polygon in the clockwise manner. So we have to go from I4, we will move to I3 until we do not get the previous intersecting point. In this case, the previous intersecting point is I3. So from I4, here in the subject polygon, we will move to the clipping polygon vertex list to find where I4 is located, and from there, if we scan forward in the clockwise direction and keep on storing the vertices which of the vertices until we do not get the previous intersecting point. Here the previous intersecting point was I3, so here we got the I3, so we will end the procedure here. So this is the starting procedure, this is the corresponding end procedure here. So this was the starting procedure, another starting procedure, this is the corresponding end procedure here. So for these two sub procedures, we will get the two lists of the vertices. One list is for the first sub procedure, so we will get the vertex list I1, C, I2, and for the next sub procedure we get the list I3, E, I4. So the algorithm repeats this procedure for all the intersecting points mm, corresponding to the subject polygon. Here, as you can see, there are no more intersecting points corresponding to the incoming edges of the subject polygon, so the procedure ends here. So total procedure, if we look at, so first we have to, just to summarize the whole procedure, first we have to make two lists of the vertices. One is for one list is for subject polygon. There we will store all the vertex list uh, of the subject polygons along with the intersecting points. And in the clipping polygon, we will store all the vertices corresponding to the clipping polygon and along with its intersecting points. So now we will find the first intersecting point generated by an incoming edge of a subject polygon, and we will start the procedure from there by following the subject polygon edge in the clockwise manner and go on keeping the vertex as until we do not get any intersecting point for an outgoing edge of a subject polygon. Once we get the outgoing edge of a subject polygon, we will start scanning the clipping polygon edge in the clockwise manner, and we will go on following the clipping polygon edge from that point until we do not get the previous intersecting point. And once we get the previous intersecting point, we will end the procedure in the sub procedure there, and from the next intersecting point corresponding to the incoming edge of the subject polygon, we will restart the sub procedure again to follow the subject polygon edges in clockwise manner, and procedure repeats, uh, and keep on tracing the vertexes until we do not get any intersecting point corresponding to the outgoing edge of a subject polygon. Once we get that outgoing intersecting point, from there we have to scan the clipping polygon list, and from the clipping polygon list we will scan forward in the clockwise manner to find out the previous intersecting point. Once we get the previous intersecting point, we will end the sub procedure there, and procedure repeats in this way. By this way, finally, from the output vertex list, we can draw the final clipping region. Like for here, two lists are generated in the vertex list in output. So I1 is here. So I1, then C was here, C was here, then I2. So I1, C, I2. Then from the another list we get I3. So I3 was here, E and I4. So we get I3, E and I4. And it is worthy to note that there will be no extraneous edges joining these two isolated clipping region. So clipped region. So one clipped region is I1, C, I2, and another is I3, E, I4, but there will be no extraneous edges. And by this way, this Wiler-Atherton algorithm can overcome the drawback of not having the extraneous edges for the concave shape polygon. I hope this algorithm is clear to you all. So if the algorithm is clear, so please try to solve some problems which I have already shown to you. Suppose for this problem, this is for homework. So apply the Wiler-Atherton polygon clipping algorithm to clip the subject polygon A, B, C, D, E, F, G, and A with respect to this clipping polygon. So we have already discussed that if you use the Sutherland-Hodgman algorithm, you will get this sort of figure. So if we apply the Wiler-Atherton algorithm, I urge all of you that this edge will not occur. So I instruct you all to solve this problem and show the vertex list like we have done for this case, and to generate the output. Okay, so that's all for today. Thanks for listening.